All right, my name's Ryan Quinn. I work with OII here in Tulsa as my day job. I'm the systems engineer for the Tandy Community Supercomputer. So, yeah, if you guys have a business that could use some supercomputing resources, we might be able to accommodate you. So I've got a little bit more about me in the slideshow. So let me get set up and see how things are going to work. Maybe kind of interesting because I may not be able to see you guys.
Do you see the share screen? Oh, there we go.
Yeah.
Perfect. Okay, it's good.
Okay, there we go.
Perfect.
All right, I can still see you guys. So, if you guys have a question, just flag me down, and I'll see if I can get you an answer. All right, so basically, we're talking about just basically Postgres. Done a little bit of work with MySQL and MS SQL in the past. Right now, I'm basically working on getting better at Postgres. That's my main focus right now. So about me, I'm a systems engineer at OII, which I mentioned. I have a little side business called sidegreen.net. I have some dogs who aren't here right now because they're little hams and they just began to weigh. I'm a Linux, Unix, like OS fan. That's what I like to work with, and I really like centralized authentication. Once you get into really big teams or just trying to get access to lots of different things without having to remember a bunch of passwords, it's really nice. So, topic background. I'm a systems guy. I'm not a DBA. So this is where this is coming from. The genesis of this topic came from a project at a former employer. They're a heavy MySQL shop, and they wanted to get LDAP authentication working. Well, the problem with MySQL and LDAP is that it's not really baked in. It's kind of hacked on because you have to install a module, then you have to map everything to it. And that kind of led me to Postgres. I'd known about Postgres for a while and all its authentication protocols. So after working with the MySQL project, I kind of started looking at that and started trying to get a better idea of what I could do with it. The next part is FreeIPA. It's a turnkey identity management solution. And at OII, we're looking at standing up a new cluster about the third quarter of next year. And we're going to be using FreeIPA as our identity management to replace our current little LDAP system. So it turns out the Postgres was a pretty good platform for testing this stuff, since it has a lot of authentication protocols that it supports. All right, software environment. I've got a mixture of CentOS 7 and Fedora 26. The servers are CentOS 7 with one client being CentOS 7. Then I've got two Fedora 26 clients. I'll be using PostgreSQL 9.6 from the PostgreSQL repos and FreeIPA 4.4.0 from the CentOS repos. And things I'll be talking about, SSL and securing communications, connection prerequisites, the PSQL, the Postgres CLI shell, pghba.conf, which is the main authentication config file, pgident.conf, which maps system users to database users, and then authentication methods and their various options. All right, so authentication doesn't equal secure communications. By default, Postgres doesn't turn SSL on. You have to manually do it in postgres.conf. Yeah, it's actually pretty easy, so it's not too bad. And you can get away with using self-signed certs if you want to do that. I have gotten it working with Let's Encrypt certs, but I haven't tested what happens to the permissions once they get upgraded or renewed, I should say. All right, prerequisites for connections. The role needs to exist, and the role needs to have login privileges. So Postgres doesn't really have a concept of users and groups. They're just roles. And the only difference between a user role and a group role is that the user role has the login privilege. And if you have a group, you can change it into a user and vice versa, just by removing or adding that privilege. And then the database you're trying to connect to needs to exist. Like MySQL, you can connect and not specify a database, and you'll be connected. But with Postgres, if you're not trying to connect to a database, or the database you're trying to connect to isn't there, you'll get punted and you'll get an error about it. And then on top of that, the role that you're using to connect needs connect privileges on the database. So there's one more level on top of all that. So you can be connected and you can connect to a database, but you may not have privileges to actually connect to it. So in PSQL, there's a couple things. A couple ways to work with it. On startup, it checks the $PG environmental variables, and from there you can change different aspects of it. Like PG host is equivalent to -H host name, and PG port is equivalent to -P port number, and PG database is equivalent to -D database name. And these are all documented in section 32.14 in the Postgres documentation if you want to look at that and find out more about it. And then there are two config files. There's .pgpass and .psqlrc. .pgpass stores passwords for host, ports, and databases and users. That way, if you're connecting to a bunch of different things, you don't have to remember everything or set up special scripts to connect. You can just set that and they'll figure it out. That's in section 32.15. And then the PSQLRC, it just customizes the PSQL shell once it's started. If you have a bunch of commands that you regularly run to set up your environment, you can put them in there, one per line, and it'll read it on startup and set everything for you. So there's a couple of different ways to connect with PSQL. The basic way is PSQL-H DB host. And then on top of that, you can add -U user, and you can then add a database or -D database. And if you'll notice that it takes a capital U, not a lowercase u. So if you're used to the MySQL command line, it's a little bit different. Not quite sure why they said it that way. I haven't been able to find anything about it, but they did. All right, any questions so far? All right. Okay, cool. Just let me know if you do. All right, pgident.conf. This maps system usernames to database names. The syntax is the name of the map, the system name, system username, and then the database username. And you can have multiple maps with the same name, but have different system username and different DB usernames, so you can kind of mix and match. It's pretty handy when you have different things you've got going on. You can use regex in the system username, but it's slightly nerfed regex, so it's not 100% regex. Like you can't do /igm on the end. And if you're using the PostgreSQL repos, it's in varlib PGSQL. 9.6 data on CentOS and Fedora. The pghba.conf is the main client authentication file. The HBA stands for host-based authentication, if you're curious. And this is going to be the central file we're going to be working with. That's in varlib PGSQL 9.6 data on CentOS, Fedora, and using the Postgres repos as well. All right, syntax rules. Fields containing white space need to be double quoted. Yeah, and it turns out that double quotes is important detail. I was trying to do some stuff with single quotes, and it was telling me it was invalid syntax. So if you get that error, if you make some changes and you get that error, check your quotes. The hash can be used to comment text. That's always important to know. That way you can leave yourself little notes about what exactly you're doing. And then and comments can be inlined. So this is really nice. So if you can put a line in there, you can tag the comment to the end. Blank lines are ignored. So you can put as many as you want, and it's not going to change anything. And it's one record per line. So you have one entry. Once you're done with that, you put a new entry in. So it makes it pretty easy to read. And then records cannot be continued across lines. Like if you used to bash, putting a shell, / at the end, or backslash at the end, you can continue. Yeah, it doesn't have on Postgres. Everything has to be on one line. And some of the LDAP examples are going to get pretty hairy. So it's kind of odd that they don't allow that. All right, parsing rules. The file is read top down, and it's read one record at a time until a match is found. This means is as soon as it finds something that matches the connection parameters, it's gonna short circuit and try to use that rule. And it's accepted or rejected based on the record. So order is really important. So if you have an LDAP rule before, like just a local rule, and you're using the same username, it's probably going to try the LDAP rule first. So if something isn't working and you think it should be, check your order. All right, record format. The general format is socket type, database, role, and then optionally address, subnet mask, and then authentication method, and then authentication options. And we've got two types. We've got Unix sockets and network sockets. The Unix sockets are local only, but you can use file system permissions on them. As you can see, the address and subnet mask aren't part of Unix sockets. And then on the network sockets, they're usually host, database, user. And you can set a domain name as the host name, or you can use a CIDR formatted IP address, or use a IP address IP mask combo. It's kind of whatever you're most familiar with or comfortable with. But the thing about the host name is that DNS does need to be working, especially reverse DNS, because the first thing it does, it's going to go out and do a reverse DNS lookup to make sure the IP address matches the host that is sent in the connection request. Next thing it's going to do is try to do a forward lookup where it's looking up the host name and to get the IP address to make sure they both match. And then, some more about the socket types. Yeah, if you don't put a local entry in there, that disables all Unix sockets, which is nice if you want to turn all that off and just want to do TCP IP only. And then we've got host, which will match connections with or without SSL. And then host SSL forces SSL to be enabled. Like if you're trying to connect without SSL, it's gonna fail. And then host no SSL requires that the connection does not have SSL. So if you have one client that just does not work with SSL, you can force it off. Or one client you want to monitor with TCP dumps. That's the database field. This specifies which databases the record will match. If you do just put a single DB name in there, it's going to match just that database. If you put all in there, it's going to match all the databases. That's their version of a wildcard. Same user, and that indicates that the DB name and the username must be the same thing. So if you have a user 1 trying to connect to a database, it has to have a database named user 1. And then the same role, that means that the DB name must equal the role name, and the user must be in the role name in the role. So if you have a database named app0, and you're trying to connect with user 1, well, user 1 needs to be a member of the app0 group role before you'll be able to connect. And then you can do an app file name to source an external file. By default, it's relative to where the pghba.conf file is. And you can change that by providing the absolute path or a relative path. And you can also specify as a comma separated list of DBs and files. So you can do DB0 or comma user 1, comma app DBs, and that all work. In the user field, this specifies which roles the record will match. So all matches all roles, so it's valid, and you can do a plus role, which matches role members which are directly and indirectly a part of the role. So Postgres has the concept of inheritance. So if you have a sales role, a sales group role, and then an analytics group role, and the analytics is part of sales, and user 3, as part of analytics, will inherit all the permissions from the sales role. That can be turned off with by specifying no inheritance when the account is created, or you can remove the inherit privilege. And the user field also takes a comma separated list. You can do users, you can do group roles, or you can do a file. And next field is the address field. This only applies to network sockets. It takes same host, which means the connection must be coming from the server's own address. And then same net. This just means that any address on the same subnet as the server will match the role. And then you can specify host name, which is the DNS name, or you can just specify a domain. If you do .domain.tld, that'll match anything with that domain name. So if you have a workstation like wks0.domain.tld, that would work. Or if you have c1.subdomain.a.domain.tld, that would work as well. And you can specify it in the CIDR notation, which is IP address / the bit mask, and just regular IP address subnet mask combo. All right, the next fields are authentication method and options. The auth method is the authentication method keyword, and the auth options are the options for each method. they're all specified in name equal value style. So anytime you see an option, you need to specify a value for it. There's one universal option. It's the client cert equal 1. What this means is that it's telling Postgres that the client needs to provide a valid certificate in order to connect. This is kind of interesting in that it forces SSL on the connection. So if you need to force it, this is a way to do it. Authentication methods. We can do peer authentication, trust, ident, password, PAM, LDAP, GSS API / Kerberos, certificate, SSPI, radius, and BSD authentication. So I'm not going to be talking about SSPI, radius, or BSD. The SSPI authentication is Windows only, and I don't have any Windows machines to test it with. I need a Windows client and a Windows server to be on both ends for it to work. It's mainly used for negotiating whether the client will use Kerberos or NTLM to authenticate. And anything above Windows 2000 should use Kerberos. Radius is really cool. It's a Swiss Army knife network tool, and it really opens up the door for lots of different authentication mechanisms. Most Radius servers can run custom scripts to glue stuff together. Like, for instance, FreeRadius can. And I've seen that used to authenticate users against the Auth2 via web API. So if you have, it's definitely something to check out if you have a bunch of odd authentication methods. And BSD, it's only really available on OpenBSD at the moment. I do have a project about how to hook the BSDs into FreeIPA, but that's a different project. For pure authentication, this is only supported on local connections. Basically, what it means is that Postgres is going to ask the OS if a user exists. Whenever it gets a connection, it's going to ask if user 1 exists according to the OS, and then they'll accept or grant the connection based on whatever is returned. Its keyword is peer, and the two options are map, or the one option is map. And as an example, entry, you do a local all Postgres peer. What this means is that it's going to accept the Postgres user for any database. All right, trust authentication. There's really no authentication with this one. If you have a connection, if you connect with a valid user, you're going to get access. It's kind of interesting for testing, but overall you probably don't want to run it in production. There are no options because there's nothing really to control on it. The only thing you can do is limit the IP addresses that can connect. Like in the little example host, all with 0/0, and that will let anything and everything connect. And then reject. This basically means no one gets connection. Anything that matches this rule is going to get dropped. So if you have one machine that really doesn't need to be connecting to a database, you can specify that one as reject, or specific users, or just kind of whatever you'd like. Ident. This checks the identity service on the client to see what username the OS machine thinks that the client is. This is interesting. It's really old, and you probably won't see it. It's just kind of interesting how it works. Like, basically what it's going to do is the server is going to send a request back to the host on the ident port, and it's going to ask what user is associated with the local port that's connecting to the server port. So you could do 6131 connecting to 5432, and the OS will send back its like user 3 or whatever. Unfortunately, it's really easy to spoof this. Like during testing, I was able to set up a little ident server and get a user to connect as the Postgres user. So it's definitely not really something you want. And its option is map, and it maps system users to database users. Then in the example, it's it's a host SSL. It's forcing SSL on it. And it will connect to app1db, like all users, and it's specifying the C1 client with a method of ident and so using the ident map to map system users. Password and MD5 authentication. These are username and password authentication methods, and they're really the most familiar ones. Password sends the the password in clear text, so it is vulnerable to packet captures. And then, so if you're going to use it, you probably do need to enable SSL on the connections just for a little bit of security. The next method is MD5, which does a MD5 hash of the password. What it does is it's a hex digest of the username and password with MD5 prefixed. So it's a little bit more secure, but maybe not necessarily that much more. You should probably force SSL on that one as well. Version 10 is going to use a Scram SHA 256, so that'll be a nice upgrade. And then in the two examples, we've got the one that anything on the 192.168.1.0 network can connect with the password. And then the second one, anything in the analytics role can connect. So the PAM authentication method, this exports all the authentication to the host OS. Postgres is going to query the host OS and with information for the user and password that's receiving. And the host OS is going to pass it through its PAM stack and use whatever authentication methods it has configured to authenticate the user and user. This is kind of cool, especially if you've got network authentication going. If you've just got local, keep in mind Postgres doesn't have a way to read Etsy's shadow, and you'll have to adjust the permissions on that. So, and generally that's not really anything you want to do. You want to just leave the Etsy shadow alone, but it can be done. Its options are PAM service and PAM used hostname. The PAM service sets the PAM service name that Postgres will use when passing things into the PAM stack. It defaults to Postgres, but during my testing, I noticed I had to set it to PostgreSQL. So that's something to keep an eye on. And PAM use hostname isn't necessarily used that often. The PAM stack doesn't really use it, and most of the time it's up to the application that's going to be authenticating against. All right, got a little example down there. Connecting to AppDB, all users, excuse me, on the /24 using the PAM service PostgreSQL name. All right, LDAP. And it's the LDAP keyword, and there are two modes. There's simple bind mode and search plus bind mode. They each have options which are exclusive, so you can't mix and match. And LDAP is very similar to just regular password authentication in that it passes the user password pairs to the LDAP server. This is kind of limiting, since one of the things about LDAP is that you can create groups and group items together. But the way Postgres does it doesn't look at groups at all. So you can have a group, but groups, but they don't mean anything. All right, things to know about LDAP. The DN is a distinguished name, and it's the location of the objects in the LDAP tree. And when someone says binding to the LDAP server, that's domains that connect to it. Anonymous binds don't require an account. Regular binds require an account. This is really dependent on the LDAP server you're working with and how it's configured. Because LDAP is pretty free form, and you can do a lot of different things with it. You can change the tree around. You can change the names of different things, and you can specify whether anonymous binds are allowed or they're disallowed. So common options is LDAP server, which is a space-separated list of servers. Then LDAP port, and this defaults to the LDAP lib's default port. And most of the time that's 389, but depending on how it's built, it could be different. LDAP TLS enables or disables encryption on the LDAP servers. Postgres is kind of quirky. Well, I guess not really quirky. It's standards compliant in that it doesn't support the LDAP S protocol. It's been deprecated for a while. Quite a few things still run it. So whenever you add LDAP TLS, it's going to send a start TLS request over the regular LDAP port to the LDAP server. And that's how it's going to turn on encryption. Simple bind mode. This uses the user account for LDAP connections. Basically, what it's going to do, it's going to take the provided username and password and create a DN out of that. And it's going to send that to the LDAP server and see what it gets back. And for options, there's the LDAP prefix. It's the string used to form the first part of the DN. And then the LDAP suffix, which is the rest of the DN. I'll get into a couple of examples here in a second and show everyone what that actually looks like. And then a couple things to keep in mind. LDAP suffix needs to begin with a comma, or it's not going to work. You're going to get a malformed DN and the server will reject it. And then, once again, use double quotes. So in the good example, this is what the server is going to do. It's going to prefix the LDAP prefix, and then it's going to add the LDAP suffix to the username. As you can see, the good example has a comma right after the username, and the bad one does not. In search plus bind mode, this uses a fixed account for LDAP connections. What this means is that you're gonna need a dedicated account and provide the user DN and the password in the Postgres config to allow it to connect to the LDAP server. And then you can set it the LDAP base DN. This is the root of where it's going to start the search. And then LDAP bind DN is the account that it's going to use to bind with, and then LDAP bind password is the password for the bind account. LDAP search attribute is the attribute the username is going to be under. In different LDAP systems, you can see CN, and for IPA, it's UID, and I believe Active Directory uses SAMA something. I think SAMA account. And then LDAP URL is an alternate way to specify the same parameters. It's a little bit more limited than just using the full options. So these text blobs are some of the connection parameters I came up with. The first one, this is just a regular, it's a regular simple bind account. As you can see, you're specifying LDAP prefix as UID equals, and then LDAP suffix is the rest of the DN. The second example is a bind plus search, and as you can see, that thing is actually pretty huge. And if you're looking at that from the command line, that can be kind of annoying to try to read. And then the third example is the LDAP URL example of a bind plus search. As you can see, it's a little bit more compact, but does have another option. It's the sub option at the end. I couldn't figure out what that actually stood for, but check the documentation. There's I think 3 more things you can change it to. Then GS API / Kerberos. This is one of my favorites. This is one authentication method that really started everything. If you're not familiar with it, it's ticket-based authentication. You connect to the Kerberos server and get you a ticket, and that ticket grants you access to various things. It says you're a valid user, and you can authenticate things and access services. Once again, authentication is secured, but communications is not. So you probably need to set the host SSL on this as well. GSS is the keyword, and its options are include realm, which includes or removes a realm from the username. This is important when you're doing identification mapping, and when you're creating users in Postgres. Because if you include the realm, your entire username is going to be like user1 at the realm name. It could, for instance, like it's user1 at a.domain.tld. So you'd need to create a user that's user1 at a.domain.tld in order for it to match. But if you don't want that, you can strip off the realm name. You can just do user1. Maps identities. Caribou realm. This controls which realms match the record. So if you have multiple realms, but you only want a certain one to be able to access certain databases or the database server at all, this is what you'd use to limit that. Certificate authentication. So this is kind of a cool method. This requires client certs and as well as server certs. So I couldn't actually get this to work, so I need to do a little bit more work to figure out how to get this working. But I think it is all down to CA bundle, because I was trying to use self-signed and I need to get the CA into the OS's cache. And the only option it takes is map. So conclusions. Postgres has riches of authentication methods. We've got 11 to choose from. So it's pretty much whatever you want to do. Some authentication methods are more complicated than others, like setting up a CA and getting certificates to work. And use host SSL as much as possible, because the communications aren't encrypted by default. So, any questions?